Our final presentation before our break. We'll have a 15-minute break here after this presentation. But first, we have spatial assessment of tomato spotted wilt virus to varying gap lengths within uniform peanut stands. And our presenter is Brad Davis.
Hello, everyone. I hope you're having a great day. As Dr. Kimmerat mentioned, my name is Brad Davis. I'm a graduate student at the University of Georgia under the direction of Scott Tubbs, and I'll be presenting on spatial assessment of tomato spotted wilt virus to varying gap lengths within uniform peanut stands. An overview of what we'll be discussing will be the introduction, objectives and hypothesis, materials and methods, results and discussion, conclusion, and then we'll move into future research. Tomato spotted wilt virus can affect growth and reduce yield. As many remember, in the late 90s, there was a substantial loss in yield due to the devastating effects of tomato spotted wilt virus in the southeastern United States. And it is known that thrips is the vector for TSWV, and western flower thrips is the most prevalent vector for TSWV within peanut stands. There's been many management practices that have been introduced to combat against TSWV. Resistant cultivars have been introduced, insecticides, specifically phorate, and management practices such as seeding rate, planting day, cover crops, and tillage practices that have been introduced to help reduce the TSWV incidence. We'll now move into objective and hypothesis. The first objective is to identify the optimal method of replanting in a uniform stand with varying gap lengths to minimize TSWV incidence. And the second objective is to identify the differences in TSWV incidence at the gap edges, adjacent rows, and within the gaps in relation to the missing segments of the row. The hypothesis for the first objective is there is no difference of TSWV incidence among the replant methods of no replant, only in gap, and full row. And for the second objective, there is actually three hypotheses. There is no difference of TSWV incidence among any of the treatment variables, which we'll mention later in the materials and methods section within the adjacent row of the gap. There is no difference to TSWV incidence among any of the treatment variables at the gap edge. And additionally, there is no difference of TSWV incidence among any of the treatments within the gap after the replanting had occurred. We'll now move into materials and methods. The location is in Tifton, Georgia. The initial planting date was April 28th for both years in 2018 and 2019. The replant date was May 14th and May 16th. The plant population for every plot, each row was thinned back to a population of 6.6 plants per meter with a check plot at 13.1 plants per meter in each row. Gap length was 61, 122, and 183 centimeters, and each of these gap lengths occurred once for one treatment and twice for another treatment. The replant method was placed approximately 8 centimeters to the side of the initial row. That can be seen in this picture in the upper left-hand corner. The replant is there to the right of this initial row of planting. The replant methods are none, which can be seen in the yellow oval in the upper right-hand corner labeled with the A on the picture, and gap only, which is in the B picture in the lower left-hand corner in the blue oval, and full row, which can be seen in the lower right-hand corner with the C in the frame of the picture with the white line. And all these rates were done at 13.1 seeds per meter. The experimental design was a randomized complete block with 4-row plots at 0.9 meter row width and 10.4 meter row length. Peanut management, all of the plots were irrigated. We used Georgia 06G and a single row pattern. And we followed UGA extension recommendations for the management of the crop throughout the growing season. Digging dates were based on majority maturity profile. No replant and gap only were dug before the full row based on this maturity profile. No replant and gap only were dug September 14th and September 17th. And full row replant was dug on September 28th and September 26th. Harvest dates, no replant, again, no replant and gap only were harvested before full row. No replant and gap only were harvested on September 18th and September 20th, while full row was harvested on October 3rd and October 2nd. Data collection was plant stands, yield, grade, which is percent total sound mature kernel, and percent TSWV. And for this presentation, we'll be focusing on percent TSWV and a mention of yield in one of the graphs. Data analysis, we used Proc-Glymix and SAS 9.4 with a mean separation using Tukey's HSD. And Proc frequency, SAS 9.4 with Pearson's chi-square test. TSWV hits were collected on an 8 centimeter basis. You can see the tape measure down the middle of the row here. And once we identified where a TSWV hit was, as outlined in this blue oval, we then started our data collection here at this point and recorded it all the way to the end of this point, being the stopping point. The picture in the middle shows Dr. Kolber trying to identify whether the TSWV is actually occurring at the gap edge or if it's actually back towards the crown of the plant a little bit. The picture in the top there that just showed up is an expression of the virus, the lightning bolt expression. And then the picture at the bottom is a more traditional expression of the disease. The picture to the right shows what we did once we collected the data. We then put it into Excel and assigned a color to the healthy plant, which was green, a color to the gap, which was yellow, a color to the red, to the TSWV hits, which was red, and then an additional color to TSWV that occurred within the gaps. And what we did once we saw this kind of presentation, we saw how the TSWV was occurring at the gap edges here, and then sometimes it would occur in the adjacent rows. And then again, you can see where you had it occur in the adjacent row from this gap here, but then once we replanted, the thrips migrated back into the gap where the new growth of the peanuts plants were. And that kind of representation was what spawned the idea of where, when we're looking at these gaps, does the gap, the presence of the disease, does it have any relation to the gap in the adjacent row at the gap edge or within the gap once it was replanted? We'll now move into the results and discussion. What effect did TSWV have on pod yield? The y-axis shows pod yields in kilogram per hectare, and the x-axis shows TSWV percent. It has a negative relationship with a p-value of 0.001, and it shows us that for every 10% of TSWV increase, there was a 384 kilogram hectare pod decrease. What effect did replant method have on TSWV? No replant and gap only had the most TSWV incidence at 33 and 35% respectively, while full row replant had the least TSWV incidence at 26%. Now we'll be focusing on what effect did the gaps themselves have on gaps and replant method and frequency, all the variables, what effect did they have on the presence of TSWV in the adjacent row and in the gap edge and within the gap after replanting. That's just an overview of what will be coming within the next few slides. This graph here shows adjacent row, and we're looking at gap lengths of 61, 123 centimeters, and 183. And the y-axis shows percent TSWV, and it shows us that the 61 centimeter gap had less TSWV incidence than the 122 and 183 centimeters by 22 and 26% respectively. Full row replant. We're now looking at the gap edge, and you will see that the replant methods are on the x-axis and percent TSWV is on the y. And this occurred for both years in 2018 and 2019. And we can see a similar relationship between the replant methods and TSWV percentage for both years. And it shows that full replant decreased TSWV incidence at the gap edge for both years. And full row replant had less incidence than no replant by 11% in 2018 and 30% in 2019. And we're now looking at in the gap after a replant did occur, whether it was in the gap or full row. We see that 61 centimeters had the less TSWV incidence than 122 and 183 within the gap, and it was 24 to 30% less respectively. We'll now move into the conclusion. Increased TSWV incidence, decreased yield. Full row replant reduced overall TSWV incidence. The 61 centimeter gap had less TSWV incidence within the adjacent row than the larger gap lengths in 2018. Full row replant minimized TSWV incidence at the gap edge for both years. 61 centimeter gap had less TSWV incidence within the gaps than the larger gaps lengths within the year of 2019. And we'll now move into future research. I would like to see what the planting date, what effect that would have if we at different dates. Would it affect the TSWV incidence if it was planted earlier than the date we planted, and whether it was planted later, as well as replant date within each of those planting scenarios? Cultivars, I would like to look at some of the high oleic cultivars, as well as some of the newer varieties that came out to look at the susceptibility to TSWV in relation to those gaps. And then seeding rates for the replant method. Is there a lesser rate that producers can use in order to achieve the same goal? Acknowledgements, I'd like to thank Dr. Albert Colbreth, Dr. Scott Tubbs, Zach Cromer, Hayden Godwin, Anna Azevedo, Georgia Peanut Commission, National Peanut Board, and Georgia Crop Improvement Association. And there's my references. And thank you for your attention. I'll take any questions, comments, or discussions at this time.
Very good. We have time for questions if there are any. First question would come is, why would you believe that if you fill in the gaps with your replant, why is that less effective in reducing spotted wilt severity than if you replant everything, if you're filling in the gaps anyway? Why is there a greater reduction in spotted wilt by replanting the entire plot as opposed to just filling in the gaps?
Well, my thought would be that it would cover more of the bare ground, considering that the plots that we had were reduced plots to the optimal seeding rate. It would actually reduce the bare ground, which would negate the thrip pressure coming into the bare ground. So if you just plant within the gap at 13.1 seed per meter and you leave the rest of the field at 6.6, then the thrips are more likely to come to the lesser populations than they are if you were to replant them and get a full population or the optimum population that we would recommend.
Okay, good. The second question is this, and that is, have you done any analysis between cost of seed versus loss to spotted wilt based upon seeding rate or replant decisions? And I guess the question has
I'm
to
sorry, I
do.
didn't repeat the first question. The second question, have we done any cost analysis to seed in relation to TSWV incidence and the replant method? We actually have not, but I have reached out to a couple economists, and they're in the process of getting that analysis to us. So I'm really excited to see it, because the hope is that it still will be beneficial for the producers.
Okay, and one last question. This comes from Mark Burrow. Replanting whole plant delayed harvest. What would yield be if harvest was not delayed?
The question was, replant and full row delayed harvest, what would the yield be if harvest was not delayed? Harvest would be close to the same, as the kernels are there. They just wouldn't be full and they wouldn't be mature, and the quality of seed would be drastically affected. They just need a little more time to backfill into the kernel, and that's really the purpose of the maturity board, is to identify when they're going to mature into that optimum window of harvest.
Excellent. And that concludes the time we have for questions. Thank you for the presentation.